Hi everyone and welcome back. If you have been working with Python for a while, you have probably written some scripts that solve problems step by step, and this is called procedural programming. But as your projects get bigger, especially in the world of network automation, the approach can get a little bit messy. That's where object-oriented programming, or OOP for short, really shines. So in today's video, we are going to break down object-oriented in a way that makes sense for network engineers. We will start with where object-oriented programming came from and how it found its way into Python. Then we will talk about why you might want to use it in your automation projects. And I promise it's not just about writing fancy code, it's more than that. After that, we will then dive into the core object-oriented programming concepts in Python, where we look at classes, objects, encapsulation and inheritance, and abstractions. So these might sound a bit intimidating right now, but by the end of this video, they will feel like tools you can actually use in your own network automation scripts. So after that, we will then compare procedural programming to object-oriented programming so you can see the difference in action. And of course, we will wrap it up with a live demo so you can see everything in action and then start applying these concepts to your own projects right away. So by the end of this video, you will not only understand what object-oriented programming is and how it works in Python, but also you will be able to know how to structure your automation scripts for better scalability as well as easier maintenance and more reusable code. So now that we know where we are headed in this video, let's start at the very beginning. What exactly is object-oriented programming? So you have probably heard the term before, maybe in a course or a job description, but what does it really mean? And why should network automation engineers care about it? So let's break it down. So first things first, object-oriented programming, often called OOP as mentioned earlier, is a way of writing code that organizes everything around objects rather than just a list of instructions. So I want you to think of an object as a little package that holds both data and methods. So data, things it knows, and methods, that things it can do. This makes it easier to model real-world things in a program, like representing a car as an object that has a color, brand, and speed. And it can perform actions like starting or stopping or accelerating. So at the heart of object-oriented programming is the class, which acts like a blueprint for creating objects. So a class defines the structure and behavior an object will have, but it's not the object itself. So when you use a class to create something, you get an instance, an actual object that exists in memory, and it is ready to work. This structure makes your code more modular and reusable, and easier to maintain because you can define something once and use it many times. So object-oriented programming is built on a few key ideas. So for example, encapsulation, it keeps an object's internal workings private, exposing only what's necessary. We also have inheritance, and this will let you create new classes based on existing ones. So you can build on previous work without starting from scratch. And also we have polymorphism, which allows different objects to respond to the same command in their own way. So it makes your code more flexible. And finally, we have abstractions that hides unnecessary details so you can focus on the bigger picture. So in Python, object-oriented is designed to be as straightforward and intuitive. You can mix it with other programming styles, but when used well, it helps you structure your programs so they are easier to understand as well as grow and maintain. So object-oriented programming didn't just appear overnight. It grew out of a need to make programming more intuitive and better suited for solving real-world problems. So the journey began in the late 1960s with a language called Simula. So Simula was the first language to introduce the concepts of objects, bundling data, and the procedures that operate on that data into a single reusable unit. This was revolutionary because it allowed programs to model complex systems in a way that felt much closer to how things exist in real life. In the 1970s, Smalltalk took object oriented programming to the next level, and it was the first true object oriented language. Everything in Smalltalk was an object, and all interactions happened through message passing, and had a big influence on later languages like Java, Ruby, and Python. So Smalltalk showed the world how powerful and elegant object-oriented programming could be, not just as a feature, but as the foundation of an entire language. So by the 1980s, the concept of class-based object-oriented programming became more structured. So languages like C++ brought object-oriented programming into the mainstream by blending it with procedural programming. So developers could now define classes as well as inherit behaviors and create hierarchies, all while keeping the efficiency of C language. So this made it more accessible to the growing number of programmers that are working on increasingly large and complex software systems. So finally, when Python came into the scene in 1991, an engineer designed it with simplicity and readability in mind, but he didn't ignore the power of object-oriented programming. So Python adopted the concept like classes, objects, and inheritance from its predecessors, but kept them flexible and easy to use. This meant that programmers could enjoy the benefits of object-oriented design without dealing with the rigid syntax or complexity found in some older languages. So to sum this up, Python made object-oriented programming approachable, blending it with procedural and functional programming styles. So now that we know where object-oriented programming comes from and what it actually is, the next question is, why bother using it in Python at all? So after all, Python works perfectly fine without it, right? Well, this is where the real advantages start to show, especially when you are working on larger projects or building reusable automation tools. So let's talk about why object-oriented programming can make your life a lot easier. So using object-oriented programming in Python is all about creating programs that are easier to understand and maintain and grow over time. So when you organize your code into objects, you are grouping together both the data and the behaviors that work on that data. This means you don't have to constantly keep track of which functions belong to which pieces of data. Everything is neatly packaged inside its own unit. So one of the biggest advantages of using object-oriented programming in Python is reusability. So once you have written a class, you can create as many objects from it as you want, or even extend it with new features through inheritance without starting from scratch. So this saves a lot of time and reduces repetitive code. It also makes collaboration easier because different people can work on different classes or objects without stepping on each other's toes. Also, one of the strongest advantages of object-oriented programming is modularity. So each class acts as its own self-contained module that holds everything it needs to function. Data, for example, and its behavior. So the data is referenced to attributes and the behavior is referenced to methods. This separation makes it easier to work on one part of the program without affecting the rest. And of course, it allows developers to debug as well as test and update individual components independently. Object-oriented programming also makes Python code more scalable. So when requirements change or features need to be added, you can often make the updates by extending existing classes or creating new ones without breaking the rest of your program. This adaptability means your code can grow with the needs of the project while staying organized and efficient. Another key reason to use object-oriented programming is maintainability. As your program grows, changes become less scary because you can modify or replace individual classes without breaking the entire code base. Alright, now that we understand what object-oriented programming is and why we need it, let's roll up our sleeves and look at the core building blocks that makes it work in Python. First, there is the class, which is essentially a blueprint for creating objects. So a class defines what data the object will hold and what actions it can perform. You can think of it like an architect's plan for a building. It's not the building itself, but it tells you how to make one. From that blueprint, we create an object or an instance. So an object is the actual living version of the class in your program. So while the class defines the structure, the object contains the real data and can use the methods defined in the class. So each object can have its own unique state, even though they all share the same design. So encapsulation is the practice of bundling data and the methods that operate on that data inside the same unit. So you can protect the object's internal state from accidental changes. The next one is inheritance, and inheritance allows one class to borrow or extend the behavior of another. This means you can create a new class that automatically has the methods and attributes of an existing one. And of course, this making it easy to reuse and adapt code without rewriting it from scratch. Next is polymorphism, and it is the ability for different classes to respond to the same method name in their own way. So this makes your code more flexible because you can write functions that work with any object that follow a certain interface without needing to know its exact type. Finally, abstraction, and it is about focusing on what an object does rather than how it does it, by hiding the internal workings and exposing only the necessary parts. So abstraction keeps your code simpler to use and easier to change later. So together, these concepts from the foundation of object-oriented programming in Python, it will help you write code that's modular, reusable, and adaptable. Okay, so now that we have got the core concept of object-oriented programming, let's zoom out and see how they actually change the way we write code. So procedural programming and object-oriented programming are two different ways of approaching problem solving in code, and Python happens to support both of them. So procedural programming is the older of the two styles. It's all about writing a sequence of instructions that the computer follows step by step. It breaks tasks into functions that operate on data. And of course, this works really well for smaller programs or tasks where the flow is straightforward. However, as the projects grow, the code can become harder to manage because the data and the functions that work on it are kept separate. Object-oriented programming, on the other hand, takes a more holistic approach. So instead of separating data and behavior, it bundles them together into objects. So each object is like a self-contained unit that knows things, or data in that case. And these things can do things, which are methods, which are part of the class. So by using classes as blueprints, you can create as many objects as you need, each with its own unique state, but sharing common behaviors. And of course, this makes it easier to model real-world entities and relationships in your programs. So in Python, you are free to choose the style that fits your project. If you are building something small or quick, procedural code might be simpler and faster to write. But for larger applications, I would say object-oriented programming tends to shine because of the reasons we've mentioned earlier. However, you can even mix both approaches in the same program. For example, using procedural code for simple scripts and object-oriented programming for the parts that benefit from structure and reusability. So the main difference comes down to how you think about the problem. So procedural programming is like writing a recipe, step-by-step instructions to reach a result. Object-oriented programming is more like designing a set of tools and components that can work together. So instead of following a fixed path, you build flexible systems that can adapt as your program grows. And in the world of Python, it provides flexibility, which means you don't have to pick one forever. You can use each where it makes the most sense. Alright, so we have talked about the theory and compared different approaches and explored the core concepts. Now it's time to bring it all together. So let's jump into a live demo so you can see exactly how these object-oriented programming principles work in a real Python script for network automation. So by the end, you will see how everything fits together and how you can start using it in your own projects right away. So as you can see on the screen, we have created a file called python classes.py, and the first two lines are the import modules from the netmiko library, which is widely used for managing network devices over SSH in Python. So connect handler is the function that actually creates the SSH connection to the network device. The second import pulls in two specific exception classes, one for timeout and the other one for authentication failures. So the script can handle these cases gracefully without crashing. So in Python, we define a class using the class keyword followed by the class name, and by convention in camel cases. Each word starts with a capital letter. We can also add an optional docstring right after to describe what the class does. So the class word tells Python we are creating a new object blueprint. The network device is the name of the class, and it should be descriptive. The colon, as you can see on the screen, ends the class header and starts the body. Then in line number 5, you can see the docstring, and it is optional but useful for documentation. The next section is the init method, and it is a special method in Python that runs automatically whenever you create an object from that class. This is called the constructor. So the constructor takes details like host, username, password, device type, and secrets. These are stored as instance variables, so they can be used later when connecting to the device. It also initializes self.connection as none, so we know whether we are connected to a device or not. So without the self, the method wouldn't know which object's data it's working with. So self.host is equal host, which means on this specific object, self, create a variable called host and assign it the value passed in from host. So every time you create a new object from the class, that object gets its own separate copy of these variables. So any function inside a class is called a method. Always take self as the first argument unless it's a static method or class method. You call these methods on the object you created, not directly on the class unless it's static. So this method belongs to network device class, and when you run switch.connect, for example, Python automatically passes self, which is the switch object, to the method so it knows which device to connect to. So the connect method builds a dictionary called device params, and it contains all the required connection details. It then attempts to establish an SSH session using connect handler, and if the device has a privilege exit mode or enable mode in that case, it enters it by calling self.connection.enable. It uses a try except block to catch different types of errors. So the netmiko timeout exception, it checks if the device didn't respond in time or not. The netmiko authentication exception, it checks if the username or password or secrets are wrong. And then finally, we can see the general exception, and that gets triggered if there are any other connection issues. If the connection succeeds, it prints a confirmation message and returns true. Otherwise, it prints an error and returns false. So the disconnect method, it checks if there is an active self.connection. If yes, it calls .disconnect to close the SSH session and prints a confirmation message. This will ensure proper cleanup of the connection. Next is the send command method. This is for running show commands, read-only commands. It first checks if we are connected. If not, it warns the user. If connected, it sends the command via self.connection.send command, and it returns the output. And of course, errors are caught and printed without crashing the program, since we are using try except block. So, to define a child class or to use inheritance in object-oriented programming, you set the parent class name in parentheses after the child class name. So, as you can see, Cisco Switch is the child and network device is the parent. And because of inheritance, the Cisco Switch class automatically has all methods and attributes from network device without rewriting them, meaning it automatically gets all the connection, the disconnection, and send command functionality from the parent. So the init method here calls the super.init, and that will run the parent constructor, but it hardcodes the device type as Cisco IOS, since this class is specifically for Cisco IOS switches. The send config command method is designed for sending configuration mode commands, so it can accept a single string or a list of commands. If it's just a string, it wraps it into a list so that when we send it to the send config set, it can handle it. It also sends the configuration and it prints a success message and returns the output. If something goes wrong, however, it prints an error message. Again, since we are using the try except block. So this class is almost identical to Cisco Switch, but is meant for Cisco routers. Like the Switch class, it hardcodes device type to Cisco IOS and implements the same send config commands method. So this separation allows us to extend router-specific features later without affecting the switch code. Finally, we have reached the main program itself, and the if block contains example usage for both a switch and a router. So the Cisco Switch class example creates an instance of Cisco Switch with an IP address of 192.168.1.2, and it passes the credentials. It connects to the switch, runs a show VLAN command, and prints the output. It also sends VLAN configuration command, such as VLAN 10, as well as the name of that VLAN, which is account department. And then it runs the show VLAN again to confirm the changes. It then disconnects from the switch. And then next is the Cisco router class example. So we create an instance of Cisco router class with an IP address of 192.168.1.1. Again, it connects and then runs show IP interface brief, and then it prints the output. It also configures a loopback interface with an IP address of 10.10.10.10 and the subnet mask is /32. It then runs the show IP interface brief again to confirm the new interface has been configured. After that, it then disconnects from the router gracefully. So what I'm going to do now, I'm going to run the script, but before I go ahead and execute the script, I just want to log into the switch and also log into the router and then issue a couple of commands just to make sure that the router hasn't been configured with a loopback interface and the switch hasn't been configured with VLAN 10. So as you can see, this is router 1 on the left hand side and there is no loopback interface being configured. And if I issue the show VLAN on switch 1, you can see that there is no VLAN 10 being configured on switch 1. So I'll go back to my code and then execute the script. So what happened here is that the script have managed to connect to switch 1 successfully, executed the show VLAN brief, and you can see that VLAN 10 hasn't been configured. And then after that, it pushed the VLAN configuration. And as you can see, the VLAN configuration has been added. So you can see VLAN 10 and the name of that VLAN is account department. And then if I scroll down, you would see that we have successfully logged into 192.168.1.1. We issued the show IP interface brief, and then we pushed the configuration into the router, and then we have executed the same command, and it shows that there is a loopback interface 0 that has been configured successfully, and it's in the up state with the correct IP address of 10.10.10.10. If I were then to go back to my terminal window and reveal the same commands, you would see the new changes. So you can see that loopback interface 0 has been configured on the actual router. and you will be able to see that VLAN 10 has been created with the appropriate VLAN name as well. So this script provides a reusable object-oriented framework for managing network devices. The network device class defines the core connection and disconnection and command execution features. The Cisco switch and Cisco router classes extend it, specializing in device-specific configuration tasks. So by using classes and inheritance, we avoid duplicating connection logic for every device type. We also can easily extend functionality for different vendors or device types by creating new subclasses. And we also keep the code clean and organized and easier to maintain. And finally, we make it simple to scale automation by adding more devices with minimal code changes. So that's it for this video. I hope it was informative for you. If you found it helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions or thoughts, feel free to drop a comment below. And to read more about this topic, be sure to check out my blog. You will find the link in the video description below. And remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.